Hello students, hope you are doing well. I am Suryam, Assistant Professor, Department of Pharmaceutics, Vishnu Institute of Pharmaceutical Education and Research, Narsapur. Today we are going to discuss about the HLB scale. This topic is from Physical Pharmaceutics 2. Let us start the concept. The HLB scale is invented by Sir Griffin in the year 1949. So let us go into this topic. So this HLB scale is invented by Sir Griffin in the year 1949. The major use of this HLB scale is used to determine the surface active agents. The surface active agents, also known as surfactants, to determine the nature of the surface active agents. So this nature of the surfactants will be two types: hydrophilic in nature and the second one is lipophilic in nature. So this hydrophilic and lipophilic in nature. So generally, by using this HLB scale, we can determine or we can know the surfactant belongs to either hydrophilic in nature or in lipophilic in nature. So generally, this hydrophilic and lipophilic is completely based on the nature itself. So this, coming to the hydrophilic and lipophilic of the surfactant. So this will be the surfactant, and this surfactant is consist of head portion and tail portion. This is the HLB scale. So this HLB scale contains ranges from 1 to 20. So in this 1 to 20 ranges, the lower range, that is 1 to 10. 1 to 10 always indicates lipophilic nature. And the higher range of this HLB scale, that is 10 to 20. This higher range is always indicates the hydrophilic nature. Okay, so this lipophilic nature surfactants, lipophilic surfactants always try to bind with the oils or fats or lipids as well. Next portion is hydrophilic portion. This hydrophilic portion ranges from 10 to 20. This hydrophilic always binds with water molecule. So as we discuss the structure of the surfactant, this will be the structure of surfactant, and as we all know that this is the head portion. This is what? Head portion. and this is tail portion. Okay, so always head portion is always tries to bind with water. That is why it is named as hydrophilic in nature. Hydrophilic nature. Hydrophilic in nature, and also known as lipophobic. What is that? Lipophobic nature. Hydrophilic or lipophobic. And this tail portion is refers to lipophilic nature, and this lipophilic portion or lipophilic nature is also known as hydrophobic. But this lipophobic or hydrophilic means they will be known as water loving. That means oil hating. Whereas coming to this lipophilic in nature, these are lipid loving or oil loving. At the same time, this is also known as water hating. Okay, say for example, if we add a surfactant into a substance, then what will happen is, so if the surfactant or the substance is water substance, so the head portion will goes together and they will form a boundary like structure that is called as micelle. Let us see. So now we added, this is the water sample, and into this water we added some surfactant. So now, as we know, surfactant is containing two portion, hydrophilic and lipophilic portion. So this is water molecule, hence the head portion will comes to closer to this water molecule and they will be form a boundary like structure like this. Now this will be indicated as a boundary like structure. In the same surfactant, if added, the same surfactant is added to oil portion. Say this is the oil portion, and now what will happen? Since we are adding the surfactant to the oil portion, then the surfactant, the tail portion of the surfactant will attach like this. The tail portion will be attaches to the oil portion, and here again we can observe the formation of the boundary, boundaries like this. This is called as formation of micelles. According to the HLB scale, the ranges will divide the different type of surfactants, as we can see in this diagram. So first class of the surfactant is anti-foaming agents. So this is the range of the anti-foaming agents, first class, and from 3 to 8, this indicating water in oil type of emulsifiers, and from 7 to 9, this portion indicates the third class. This portion indicates wetting and spreading agents, and similarly from 8 to 16, this indicates the fourth class of the surfactant, that is oil in water type of emulsifier. And then from 13 to 16, from 13 to 16, these are considered as detergents. These are the detergents. Next, from the 16 to the end, from 16 to end, from 16 to 20, from 16 to 20, this indicates solubilizers. So first, antifoaming agents 1 to 3. This is based on the range of HLB scale, based on range of HLB scale. So first class 1 to 3, that indicates antifoaming agents. Examples for antifoaming agents are castor oil, cetyl stearyl alcohol. Next, coming to second class, that is the range in the scale is 3 to 8. This indicates water in oil type of emulsifier. The example for this is diacetyl tartaric acid, and then the third class, that is the range in the scale is 7 to 9. This 7 to 9 indicates wetting and spreading agents. Example for this wetting and spreading agents are SLS, sodium lauryl sulfate, and then the fourth class of the range is, that is 8 to 6. Here this indicates the oil in water type of emulsifier, The example for oil in water type of emulsifier is sodium phosphate. And then similarly, the fifth type of surfactant here is the range 13 to 16. This indicates detergents. And example for the detergent is again SLS. And last class of this range is 16 to 20, that is solubilizing agents or solubilizer. The examples of the solubilizer is sorbates, monosorbate class, and polysorbate. This is about the different types of surfactant which can be determined by the range of HLB scale. As we know, the HLB scale is ranged in between 1 to 20. So generally in this, the first 1 to 10, this range indicates lipophilic, and then 10 to 20 range on the scale, that indicates hydrophilic in nature surfactants. Next, determination of HLB scale. So the HLB scale value can be determined by different methods. Here we will be having two different methods, method 1 and method 2. So in these two methods we can determine the HLB scale. So determination of HLB value. So in the first method, we can use the formula, that is HLB is equals to E plus P divided by 5. E plus P divided by 5, where SE stands for percentage weight by weight ethylene oxide, and P polyhydric alcohol group. Polyhydric alcohol group. This is the method 1. And second method, this method is also known as saponification method. The second method is also known as saponification method. In this saponification method, we need to go for the hydrolysis of a particular substances, which we need to know the HLB value. So in this method, the HLB will be calculated by this formula, that is HLB is equals to 20 into 1 minus S by A. By using this formula, we can calculate the HLB value of the given substance. So in this, what is S? S is saponification. S is the saponification value. S is saponification value, and A is acid value. In the above second formula, we discussed about the saponification and the acid value. So what is saponification? First thing, saponification, the amount that requires to neutralize the fatty acids. This is known as saponification. The amount of the KOH, that requires to neutralize saponification method. In this, we can get the S value, and coming to the acid value, this indicates the purity of acids which we used in the hydrolysis or neutralization process. Next, by above two different methods, we determine the HLB value. And coming to the applications of HLB scale, so there are a lot of applications are there in the HLB scale. By knowing the surfactant, which whether it is belongs to hydrophilic or it belongs to lipophilic in nature, we can manufacture or we can prepare different type of dosage forms. So the major applications of this HLB scale, applications of HLB scale. Majorly, the HLB scale is used in cosmetic industries to prepare creams, lotions, and other cosmetic products. The major application of this HLB scale is to determine the nature of surfactant. Whether it is hydrophilic in nature or it is lipophilic in nature. This will be determined by the HLB scale itself. Next, limitations of the HLB scale. Here, of course, we will be having some limitations of HLB scale. So where this HLB scale is failed to prove some things. As we know that as the all emulsions and their stability will be affected by the temperature. But why this temperature is going to be affected the stability of the emulsion? Not only emulsions, major of the pharmaceutical products will be affected by the temperature, but this HLB concept is not able to find the proper reasons why the temperature is majorly affecting. The second limitation here is unable to define the complex formations of a substance by using multiple surfactants, and majorly it's failed to explain the concentration of the surfactant. So these are the limitations of the HLB scales and applications of the HLB scale as well. So dear students, hope you understood. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.